Hello everyone, my name is Rifqi Hizbul Islam and I'm from Padjadjaran University, Indonesia. So today I will present my research paper entitled Construction of Lateral Flow Immunoassay based on Anti-SARS-CoV-2 Immunoglobulin Y as a Diagnostic Kit to Detect Coronavirus Disease 2019. So at the end of 2019, a disease outbreak in Wuhan, China has grown into a global pandemic until today, causing high loss economy and high mortality. The disease the disease name called coronavirus disease 2019 or COVID-19, which is caused by severe acute respiratory syndrome coronavirus 2 or SARS-CoV-2. This SARS-CoV-2 is different from SARS-CoV and MERS-CoV, which has plagued before. Signs and symptoms of COVID-19 are similar to those of influenza and seasonal allergies. So, apart from developing the most effective and efficient drugs, a strategy is also needed to diagnose SARS-CoV-2 quickly and accurately in patients. Therefore, a fast, accurate, and affordable diagnostic kit is needed to detect SARS-CoV-2 in patients. Here's some sample of diagnosis methods of COVID-19 that we use today, namely chemiluminescence immunoassay, Western blot, ELISA, or RT-PCR. But all of this instrument has some disadvantages, like long detection time, require proper abilities, require practical instruments, not easy to operate, and high cost. So we have to choose an alternative method to diagnose COVID-19. There we have lateral flow immunoassay or LFIA. Why LFIA? Because it meets assured criteria. Assured means affordable, sensitive, specific, user-friendly, robust, and rapid, equipment-free, and deliverable. As we know, inside the LFIA instrument, there's an important component. There's an antibody, especially monoclonal antibody IgG and gold nanoparticle IgG conjugate. As we know, then we can see that IgG is the main component in LFIA. But in this study, I want to show you an immunoglobulin Y or IgY as an alternative antibody against IgG, because IgY has several advantages over IgG. Here's the structure of IgY. The structure is a little bit different, but its function still the same with the IgG. IgY come from chicken or avian, especially from its egg yolk. IgY has a high affinity, large quantity, low cross-reactivity, simple isolation, good stability, and high or fast productivity. IgY has less non-specific binding. IgYs do not react to complement system, rheumatoid factor, IgM or Fc receptor, or protein A or G. IgY has better success rate too. IgY has lower homology and stronger immunogenicity over IgG. So the purpose of this study is to purify the anti-SARS-CoV-2 IgY from immunized egg yolk using polyethylene glycol precipitation and theophilic chromatography methods to be applied as LFIA compound as an alternative antibody against IgG. And second is to construct an anti-SARS-CoV-2 IgY-based LFIA to diagnose COVID-19. The methodology: first, we have immunized chicken egg yolk that extracted the water-soluble fraction with 3.5% with polyethylene glycol precipitation, then precipitated its supernatant with 8.5%, and then the pellet with 12% of polyethylene glycol again, and dilate this dissolved pellet for 16 hours in saline, then 3 hours in PBS. We further purified with theophilic adsorption chromatography and concentrated with Omicron ultrafilter. Then we have purified IgY. The purified IgY is characterized its molecular profile with SDS page and its affinity with surface plasma resonance. The protein content was measured using the lowering method. And then we have anti-SARS-CoV-2 IgY, which is divided by two. The first one is immobilized on the test line of LFIA nitrocellulose membrane, and the second one is direct conjugated against gold nanoparticle. The gold nanoparticle itself is synthesized by reducing the chloroauric acid with thermal citrate reduction method. The gold nanoparticle is measured its maximum absorbance with spectrophotometer and measured the size distribution with particle size analyzer. The conjugate that we obtain is measured its maximum absorbance again with spectrophotometer and immobilized on the conjugate pad of LFIA. And all of them is constructed to be a complete LFIA kit. The LFIA is analyzed its affinity, sensitivity, and specificity with spot test analysis. Then we have anti-SARS-CoV-2 IgY-based LLVIA as a diagnostic kit to diagnose COVID-19. So here's the result and discussion. First, in the figure 1 is tell us about anti-SARS-CoV-2 IgY purification chromatogram using fast protein liquid chromatography with theophylline matrix. So here's the sample inserted step. And the second step is a washout unbound step. In this step, we use buffer A to elute the system, which contain a high concentration of salt. This high concentration of salt makes the IgY to be absorbed to the matrix. So the protein that comes for peak 1 is theoretically not an IgY. Next step is elution step. In the elution step, we use buffer B. Buffer B is used to elute the adsorbed IgY. So the IgY is loosened and eluted, so can come down as a peak 2. So the theoretically is IgY. This peak 2 theoretically is IgY. The next step is regeneration step. The regeneration step, we use buffer C that contains 30% of propanol, and there a protein come down as a peak 2. But we still don't know what is the peak 3, is it IgY or not. Next, the theoretically IgY, especially for the peak 2, we made some ultrafiltration using our American ultrafilter and determine the protein content using the Lowry method. Then we have the anti-SARS-CoV-2 IgY concentration reached 36.9 mg per milliliter in 0.7 milliliter from the one purified immunized chicken egg. The SDS page characterization must be two stain that comes from heavy chains of IgY from 65 kilodalton and comes from light chain from 27 kilodalton. So the lane 1 is about protein marker. Lane 2 is about dialysis stage of IgA purification. It shows IgA profile with other protein profile bands, so it's still not pure. Lane 3 is about peak 1. It shows not IgA profile, so it's not IgA protein. And the lane 4 is about peak 2. It shows IgA profile, so we can say it's an IgA. And surprisingly, on the lane 5, from the peak 3, it shows IgA profile. So maybe it's an IgA too, like peak 2. So next, anti-SARS-CoV-2 IgA affinity test with surface plasma resonance. In peak 1, we can see from the figure 3A, there is no show any resonance change. So it means there's no protein antigen interaction. So we can say that peak 1 is not IgY. The peak 2, we can see from figure 3A and 3B, the peak 2 show resonance change. So it means there's a protein antigen interaction. We can say that the peak 2 is IgY. And the peak 3, we can see from figure 3B, it shows resonance change 2, like a peak 2. So there's protein antigen interaction. We can say that the peak 3 is IgA 2, according to the same profile of SDS page result with peak 2. Next is a particle size analyzer result from a synthesized gold nanoparticle. The gold nanoparticle that we synthesized has particle size distribution range to 27 to 57 nanometers. So the synthesized gold nanoparticle has a nanoscale size. Next, on the gold nanoparticle IgA conjugation, according to the diagram and the table, the shift of the maximum absorbance from 522 to 532 nanometers indicated that the gold nanoparticle and IgA has been conjugated. And the last is lateral flow immunoassay spot test analysis. There's 3 tests. The A test is a negative test, B is a positive test, and C is a cross-reaction test. With the number 1 is LFIA containing anti-protein and SARS-CoV-2 IgY, and number 2 is LFIA containing anti-protein S SARS-CoV-2 IgY is a detection and capture compound. And on the A test, the LFIA was tested with a running buffer only without analyte. So we can say that there is one stain just only on the control line. So it means that negative result. we can conclude that the SOPN did not interfere the LFIA affinity. On the B, the LFIA was tested with the SARS-CoV-2 N protein sample for the LFIA B1 and the SARS-CoV-2 S protein sample for the LFIA B2. We can see that there is a 2 stain on the test line and on the control line, which means it's a positive result. We conclude that LFIA has a good affinity and sensitivity. And the last one is C. The LFIA was tested with the SARS-CoV-2 S protein sample for the LFIA C1 and the SARS-CoV-2 N protein sample for the LFIA C2. So it's a cross-reaction test. We can see that there's just 1 stain just on the control line, so it means that its result is negative. So we can conclude that the LFIA has a good specificity. The conclusion is the first, the IgY purified using the methods in this study has high purity and keeps its high affinity against SARS-CoV-2 and can act as an alternative antibody against IgG. The second is an anti-SARS-CoV-2 IgY-based LFIA has been successfully constructed to diagnose COVID-19 with high affinity, sensitivity, and specificity. So here we are the references that we are used, and thanks for watching.